Hey everyone, I'm Shakti from the Hyperswitch team. In this video, I'm going to talk about the security measures employed in the Hyperswitch application. So we designed Hyperswitch in such a way so as to meet the PCI standard. And we follow the same security principles in our own cloud environment, which is already PCI L1 certified. So in this video, I'm going to talk about two things. First, I'm going to talk about how sensitive card data flows inside the Hyperswitch application. And then we're also going to see how the data encryption process happens inside the Hyperswitch application. So first, let's start with the sensitive card data flow. So let's see how sensitive card data flows across the various components of Hyperswitch. So to begin with, the Hyperswitch client SDK will collect the card data from the customers. So this client SDK will be sitting either in your website or your mobile application. So it will collect the card data from the customer and then transmit it to the app server, which forms the backend. So this communication happens on HTTPS standards and is basically SSL or TLS encrypted. Once the Hyperswitch backend receives the card data, it will process it and send it across to the connectors for completing the transaction. This is what is represented in this flow here, and this is again happening on HTTPS standards. And the card data is now handed over to the external parties for completing the transaction. If the customer chooses to save the card during this transaction, then the Hyperswitch card vault will come into the picture. So basically, once the connector or the external party confirms the transaction, the Hyperswitch app server will try to store the card in the card vault, and the details will be transmitted using JWE and JWS encryption. So this is how it works, right? So the Hyperswitch app server will have the public key of the card vault and will also have its own private key. So it will sign the payload and it will also encrypt it using the public key of the card vault. And then the card data is safely transmitted to the card vault. So once the card vault receives the data, it will decrypt it and it will again perform AES encryption on the data and send it to the vault database. So basically, any sensitive data that we stored in the Hyperswitch card vault is always encrypted, even while at transit and also at rest, because we also encrypt the database disk. So we do this to ensure maximum security either in transit or at rest. So let's talk about the third use case where we use the card data for analytics. So on the Hyperswitch control center, we show mass card details just to provide more information on the type of card used to the merchant. So in order to satisfy that use case, the Hyperswitch app server will just store the first 4 and the last 4 digits of the card. So since this is non-PCI data, we'll again encrypt it and store it in the Hyperswitch database. And whenever the control center requires it, we will just transmit this data to the control center. This does not come under the purview of PCI because we don't store the entire card information. And by the way, any information of the customer that we store in the Hyperswitch database is also encrypted, and we follow multi-layered encryption to store all sensitive data. So this sums up at a high level the flow of sensitive card data across the various components of the Hyperswitch application. Next, we'll see how data encryption works inside the Hyperswitch application. So we basically encrypt all sensitive data that flows inside the Hyperswitch application. So this might include any external API credentials, your customer PII information, or any payment method details, including card details. So let's see how encryption works inside the Hyperswitch application. So this is how the data encryption process works inside the application. As you can see, we have 3 levels of encryption to store any sensitive data. So let's start from the right hand side. So these tables here, as you can see, store the sensitive data. These could be your merchant specific information, or these could be any external connector credentials or customer PII data. So all these sensitive data are encrypted by something called a merchant data encryption key and stored in these tables. So this merchant DEK is created for each merchant created within the Hyperswitch application, and this is stored in the merchant key store table. So this merchant DEK is in turn encrypted by something called a master key. So we store the master key in the env variable of the application, and this master key is in turn encrypted using an external secrets manager. So in our cloud environment, we encrypt the master key using AWS KMS and place it in the env variable of the application. So this is how it works. Whenever the application starts or whenever the pod is restarted, the master key is decrypted using AWS KMS and stored in the memory of the application. So this is only the process memory of the application. After that, during runtime, whenever we need to access sensitive data, this decrypted master key will be used to decrypt the merchant DEK on demand, which will in turn be used to decrypt the sensitive data and send it across. So this is how the data encryption process works, and this is how sensitive data is accessed during the runtime of the application. The same process can also be used with any other third-party vault solution, for example the HashiCorp vault. So we'll just encrypt the master key using the third-party solution and place the encrypted value in our env variable. So this is how we access sensitive data, and the same process is employed both in the Hyperswitch application and also in our card vault. And as mentioned earlier, we anyway encrypt the database disk itself to add an additional layer of security. So that sums up most of the security principles that is employed in the Hyperswitch application. So whenever you self-deploy the Hyperswitch application in your own environment, we strongly recommend following all the principles that we have covered in this particular video. That's it. Thanks everyone.